So lesson 3-2 review is all on direct variation. The key to direct variation is your y-intercept is 0. It goes through the origin, okay? And this is the equation, your direct variation equation. Remember y equals kx, which could be the same as y equals mx plus 0, where b is 0, right? Usually we do y equals mx plus b, but your b is 0. So it's important that you remember that what makes an equation a direct variation is that the y-intercept is 0 and goes through the origin. So the first set of problems is all about checking the equation to see if it represents a direct variation, okay? So give me 1 second. Here we go. So when you have an equation and you're trying to figure out if it's a direct variation, the key is isolating the y. You have to isolate the y. Okay. Okay, so on example 1, you will want to get this y by itself by getting rid of the 8 and the 4 that are on the same side with it. You always want to undo your addition or subtraction first. So the first thing that we're going to do is subtract your 8 from both sides. So subtract 8, subtract 8. Then that means you can get rid of it over here, and you're left with 4y equals 2x minus 8. Then you want to get rid of your 4. So you want to undo your multiplication and division. So that means that we're going to divide everything by 4. So we get rid of this, and we've just isolated the y. Yeah. So now we have to come back up here and follow the directions. Determine if this represents a direct variation. According to our direct variation equations, does this represent a direct variation? What does a direct variation equation have to have? 0 where the y-intercept is. But look, here it has a -2. So this is not a direct variation equation. So not ADV, not a direct variation. Okay. Okay, moving on to example 2. Again, we need to isolate the y. This time the y is on the other side of the equation, but that's okay. We want to get this y by itself. So what should we do to both sides of this equation? Divide by -24. And so we get rid of that over here. We've isolated our y. What is -6 and -24 simplified to? 1/4 x. A lot of people want to say 4, but that would be if 24 and 6 are switched. If it was 24 over 6. So 1/4 x. Does this represent a direct variation? Yes, it does. Another way that you could write it is y equals 1/4 x if you wanted to. Okay. So because this does not have a y-intercept, that means that it's 0. And so this is a DV. Okay. So that's your answer for this one. It is a direct variation. Okay, I want to see if you can do example 3 on your own. So remember, your goal is to isolate that y. Okay, here we go. All right, so you're wanting to isolate this y right here. So what is our first step? Go ahead, Christian.
Divide by -3 on all sides.
AJ.
You have a minus 9x on both sides.
Yeah. So we're going to subtract 9x on both sides. So that means that we can get rid of this here, and we're left with -3y equals -9x. I'm not writing the 0 because I don't need the 0. Okay. Yeah, divide by -3. Okay,
Okay.
and you end up with y equals 3x. Is this a direct variation? Yes. This. Okay, so that's how you do.
Miss
All right.
Logan, what I did not hear.
Okay, hold on just a second. Okay, moving on to the next section. Suppose, and I want you to look at how I do this. Suppose y varies directly with x. Remember I said y varies directly with x. So you have your equation there that you're going to be using, y equals kx, okay? They want you to write a direct variation equation that relates your two variables, x and y. Then they want you to do something else. Once you find that equation, they want you to solve for y when x is 6. Okay, so there's two things. The first thing that you are going to do, step 1, is to find k. So let's look at example 4. We're going to use the y equals kx equation. Plug x and y into the equation to find k. So our y is 12, so I'm going to plug that into the equation. X is 3, so I'm going to plug that into the equation, and I'm going to solve for k. So this is all step 1. Okay, so then to solve for k, I need to divide by 3. And 4 equals k. All right, this is actually not your first answer. Your first answer would be plugging this into the equation because it says write a direct variation equation. So your direct variation equation is y equals 4x. This is your first answer.
Wow. How many answers are there?
2.
Oh, that's crazy. The second one gonna be faster.
Yeah. So then the next thing is you are going to, step 2 is you are going to find y with x equals 6. So if using this equation, y equals 4x, when x is 6, what is y? So all we're going to do is plug 6 in where the x is. And y is 24. So there you go. Find the k and plug it into the equation. Then substitute your x with 6 to find y. That's what you're doing. All right. Now, do you think you could follow those exact steps to try to do number 5?
Maybe.
Maybe try. So the first thing I want you to do is try to find your k on number 5. So everybody go ahead and try that. All right, so using this equation, you need to plug in your y and your x. So y is 3, x is 12. Notice I just reversed the numbers from example 4 to example 5, just to show you what it looks like with a fraction. Fractions aren't always that bad. So then in order to figure out what k is, I need to divide by 12. And what does k equal? 1/4. So then I plug this into the direct variation equation, y equals 1/4 x. So that was step number 1.
So would you have to multiply 6 times 1/4?
Yep.
Oh,
And what's 1/4 times 6?
1.5.
6/4, which simplifies to 3/2. Okay.
Reducing, you can't reduce.
I did. I simplified to 3/2. I just didn't convert it back into a next number.
Wait, 6/4.
But you simplify it to 3/2.
Don't get me.
No.
It is?
You didn't fully simplify. Okay, I want you all to try number 6, at least getting it set up, okay? Okay, so this is how you should have set it up. So if we want to figure out what K is, does anyone know what we have to do? Andrew? No?
Wait, do we have to divide by
Divide by 1/3. I got 9/3.
That's why.
Okay, remember, we want to divide by 1/3,
That's what I was.
which is the same as doing what?
Multiply by
Multiplying by the reciprocal of just 3. So let me show you what's actually happening. When we divide both sides by 1/3, okay, we get rid of this, we have 9 divided by 1/3. 9 divided by 1/3. Well, we can't divide by fractions, so we change it to 9 times 3 over 1, which gives us 27. Not a lot, no.
All right,
So
what's
20.
not a lot?
But
More than 3.
Because like, they'll be like, that's not
Okay, so the equation would be y equals 27x. And then we need to figure out what y is when x is 6 in that equation. What'd you get? No. Not 174. Hold on.
So it'll be 162.
162. Okay, there we go. Okay, so that is the second section. Now we're going to move on to the third section. Okay, this one should be easy. We're just graphing equations. Okay? If our y-intercept is 0 with direct variation equations, where will we always start when we graph? The origin at 0. So my first point is going to be at 0. What is my slope in this equation? Yep, my slope would be 2 over 1. So that means I'm going to rise 2, run 1. So let's do that. Rise 2, run 1. You could go in the opposite direction.
And yeah, you can just go draw it on.
And then you just draw your line. Okay, that was easy enough. So what is our slope for this one?
-1.
Okay, so it'd be -1 over 1, right? So we're going to start at the
Origin.
and we're going to, now this is a negative slope, so that means it's going to go in the opposite direction. So if we go up 1, we have to go to the left 1. But if we go down 1, we're going to go to the right 1. And so your line should be forming in up and to the left, okay?
How would I do in digital?
Okay,
How would I do in digital?
so that's what number 8 should look like. Okay, here we go. Moving on. Number 9. What is our slope for number 9?
What is it? 1?
1 over 4. So a lot of people started, when they did this lesson, they started just going up a fourth over 1, up a fourth over 1, up a fourth over. That got a little bit confusing. So just go up 1 over 4, up 1 over 4. Or go down 1 to the left 4, down 1 to the left 4. Okay.
Why are you telling me?
And he's the only person that I can really
We're going with Sean.
Oh, yeah.
Yeah, you go with Sean.
Well, I can do
Shh, boys, you should be working. All right, on the back, we have 5 more to go. This one's a word problem, and it actually, if you follow the way that I solve the direct variation word problems, it shouldn't be too difficult. Probably the most difficult part is coming up with the initial equation. So look at this sentence right here. The pay of an employee varies directly with the amount of hours he works. So we have to figure out what the 2 variables are. Well, it's the pay and the hours. So watch, I'll read it and I'll write it. The pay of an employee varies directly with the amount of hours. And I have just written out my equation. So typically we would have y equals kx. In this case, we have p equals kh, but your p represents the y, your h represents the x, okay? And so this second part says, what is the equation that relates p and h? So we have to plug in what we're given and come up with that equation. It says that if the employee makes $90 after working 15 hours, what is the hourly pay? Well, the hourly pay is going to be your K, okay? This right here is your total pay, and this here is your hours. So you're gonna plug those into the equation to solve for K. So 90 is the pay, 15 is the hours, we're solving for K. And so what you're trying to do is figure out how much does this person make per hour. So when we divide both sides by 15, what do we get? 6. So your equation would be P equals 6H or Y equals 6X. Either one would be fine. And then they want you to graph it. Why don't we have any other quadrants than just this first one? Yeah, you can have negative hours or negative pay. So earnings, we can title the graph. What is our X? What variable represents our X? Hours. So we'll go up to, we'll say 5 hours, and I'm skipping every other one. And then our Y represents total pay, and I'm gonna go up by 2's on my Y axis. So 2, 4, 6.
really have to do all this.
Okay, and now I'm gonna graph my equation. So how am I gonna graph my equation? Rise 6, because my slope is 6, and run 1. So I'm gonna go up 6 over 1, up 6 over 1. There you go. I didn't even need to create a table for that. I could have if I wanted to, but I didn't have to.
Yeah, very big.
Okay. And it started at 0 because if you work 0 hours, you get 0 pay.
Yeah, but if you work 900 hours, then you get 5,400.
That's correct. Okay. Okay, let's go down to this next section. This one's pretty easy if you can remember the simple step that you have to do. It says, for the data in each table, tell whether Y varies directly with X. If it does, write an equation for the direct variation. So if Y equals KX, then we can figure out the constant by dividing both sides by X, which gives us Y over X equals K. All you have to do is divide Y by X. So all this is Y divided by X. And then if for every single time your answer is the same, then it does represent a direct variation. So for example, we could have y, which is negative 2.5 divided by 2, oops, and see what you get. And then 8.75 divided by negative 7, and negative 6.25 divided by 5. Okay, does anyone know what you get when you divide all of those? Yep, you get negative 1.25, negative 1.25. This will also give you your slope, or tell you if your slope is a constant slope, or your rate of change. Is it a constant rate of change? So since they are all the same, you can say yes, it does vary directly with x, y does. And my equation is y equals negative 1.25x. Okay. So there you go. Because, and you know that because every time it was negative 1.25. Okay, so what I want you guys to do for number 12 is I want you to divide each of those and see if you get the same.
I'm assuming. Yeah, I would just assume it's a no. Take this down.
Hey,
I don't know.
I'll just say 2 yeses.
Like if it's a picture, it's at least one of them has.
1.2, negative 1.
Yeah, it's more like.
So it's not
Yeah,
correct.
Oh,
It's a yes, so.
no, it's not.
I told you. It's
What
more
makes this not a direct variation?
A negative 1.2.
Right, these are both positive, but this one is negative. So here you would just put no, and then that's it. Okay. All right, last two.
She don't be happy. But she's still trying to bring it on.
Okay, for numbers 13 and 14, the directions tell you to write a direct variation equation, and then you have to graph it. So we're combining two of the things we did on the other side. So we're going to use y equals kx. We're going to plug, oh, my screen's frozen. Okay.
Oh my God.
Okay, we're going to use the y equals kx equation, plug these in, solve for k, write your equation, and graph. So let's plug these in. Negative 24 equals 6k. So what do we get for k? And our equation, once we get that, we can write our equation as y equals negative 4x. So that was the first step. And then you could graph it. So remember, to graph, you start at the origin, and we're going to go up 4 to the left 1, or you're going to go down 4 into the right 1. Shh, boys. Okay, so that was example 13. So you asked if you were going to have any other fractions where you have to divide, and yes, this next one, you're going to have to divide with a fraction. So I'm going to do this one with you. So we want to start out with y equals kx again, and plug in what they give us. They tell us that y is 18/5. And they tell us that x is negative 6, so we have negative 6k. All right, so what we're going to do is we're going to divide by a negative 6 and rewrite our problem as a division problem. So we have 18/5 divided by negative 6/1. but we have to switch that to multiplying by the reciprocal. So we have 18 over 5 times -1 over 6. Now, I like to cross simplify mine just because it makes it easier to multiply. Some of you may not. You will end up with a -18 over 30 and then have to simplify, and that's fine. You could do that. But I'm going to simplify here first. And I end up with 3 times -1 is -3. 5 times 1 is 5. Okay. So that's my K. So my equation is y equals -3/5 x.
This one wouldn't be -5. What, -1 times 5 would that be?
Well, then you would have 3 over -5, which is fine. The whole thing is negative. I want you guys to stop thinking that your 3 is negative or your 5 is negative. What you should be saying is that your whole fraction is negative. Okay?
Right?
Now you need to come over here and graph it. So we're going to start at the origin. And it's a -3/5. So we're going to go up 3 and to the left 5. Or you're going to go down 3 and to the right 5. And you have your line.
Aye.
Okay. Any questions on those?
We're done.
Yay.
Hallelujah.